Good morning, everyone. I am Jessa Pellazar, your instructor for the subject Calculus 2. So, before we begin our proper class, everybody please stand and settle yourselves for the prayer. Miss Jessa, kindly lead. Father, the Son, and Holy Spirit. Amen. Amen. So, again, good morning, class. How are you today? Did you already eat your breakfast? Okay, that's good to hear. So, you have energy to participate and listen to our lesson today. So before you take your seats, please pick up any pieces of trashes and then kindly arrange your chairs properly. And Bidel, kindly check the attendance. So before we will proceed to our discussion, let's have a review first. So who can recall our lesson last meeting? Anyone? Yes, Miss Jasril, you're raising your hand. Very good. It seems that Miss Jasril is really paying attention last meeting. So this time, we'll have an activity. I will group you into 5 and all you need to do is arrange the jumbled letters to form the correct words that are related to our topic this morning. So I will only give you 3 minutes to answer, 2 points each, and I prepare 5 jumbled letters. So if you got perfect, the group will have 10 points all in all. So there you have group 1, group 2, group 3, group 4, and group 5. So please cooperate with your group mates, okay? So are you ready? Okay. So these are the jumbled letters. Okay, so your 3 minutes starts now. Okay, time is up. So we will check if your answers are correct. So just check your own paper and just be honest, okay? You're already third year college student, so be honest. Okay, let us check. So for the first jumbled letter, the word is, yes, Miss Sayla? Okay, the word is constant. So next, the second jumbled letter, the word is, yes, Miss Jasril? Yes, exactly, power rule. For the third jumbled letter, the word is, yes, Mr. Shamir? Yes, integrals. For the fourth jumbled letter, Rex? Yes, is function. Lastly, what is your answer, Glenn? Yes, it is integration. So, who got the perfect scores? Alright, very good. All groups got the perfect score. So, You got 10 points all. So, for group 1, got 10, 10, and 10. So, based on the activity, as you observe, what do you think is our lesson or topic for today? Yes, Mr. Rex? Yes, about integrals. Another one. Thank you, Mr. Rex. Another one. Yes, Mr. Shamir? Exactly. It is all about, our topic is all about power rule for integration. So, as what Mr. Shamir said, our lesson for today is all about power rule for integration. And before we proceed to our proper discussion, Mr. Glenn, kindly read our objectives. Okay, thank you, Mr. Glenn. So, the objectives at the end of the lesson, at least 85% of the students are expected to first define power rule for integration, and second, integrate function using the power rule for integration. So, who have an idea about the power rule for integration? Yes, Miss Ayla? Okay, thank you. So, the power rule for integration allows us to find the indefinite and later the definite integrals of a variety of functions like polynomials, function involving roots, and even some rational functions. So, the power rule for integration provides us with a formula that allows us to integrate any function that can be written as power of x. So, in short, power rule for integration is a method for integrating functions that can be written as power of x. So, the power rule for integration have the formula. So, the formula, if f of x, the function of x, is equals to a times x to the raised to the power of n, then the f of x is equals to the integrals of a times x raised to the power of n dx, or with respect to x. So, for the result will be the f of x is equals to a over or divided by n plus 1 times x raised to the power of n plus 1 plus the constant c. Okay? Just remember this formula for activity later. So, this time, we will have an example. So, example number 1, the integrals of 7, we will integrate the function or the integral 7x squared dx. So, we have the a is equals to, what is the a? Miss, Miss Jessril. The constant, 7. So, the n, or the exponent, the n which is the exponent, we have 2. So, the integral 7x squared dx is equals to a. What is the a? Is equals to 7. So, we will substitute n to 2. So, we have 2 plus 1. Then, x, n plus 1. We have n2 plus 1 plus the constant c. So, 7, we will simplify 7 over 3. Because 2 plus 1 is 3, then we have x and plus 2. 2 ni siya. So, 2 plus 1, we have 3, then constant c. So, since the we cannot factor this 7 and the 3. So, the answer is 7 over 3 x cubed plus c. Do you understand, class? It's easy, right? It's simple. Do you understand? Do you get it? Okay. So, we will proceed now to the next example. So, example number 2. So, we have, so what is the a? A is equals to constant, Mr. X, 5. So, n is equals to, yes, Mr. Shamir? Yes, 3, which is the exponent. So, we will solve. So, the integral of 5 x cubed dx is equals to, what is the a? 5 over n plus 1. What is the n? 3. So, 3 plus 1. So, x, n plus 1, we have the 3, the n, 3, which is equals to 3, plus 1, plus 1, plus the constant c. So, therefore, we will simplify 5, 3 plus 4, 3 plus 1 is equals to 4. Then, x, 3 plus 1, so x raised to the power of 4 plus c. Since we cannot also factor the 5 over 4, so the answer, so this will be the answer. So, the answer, 5 over 4, x raised to the power of 4 plus c. You understand? So, questions? Okay, none. So, we will now have another example. So, the example, the radical of square root of x dx. So, first we will write this radical expression to rational exponent, the square root of x to rational exponents. So, given by the rule, which is the rule nth root of x raised to power of m is equals to x raised to power of m over n. So, the numerator is the exponent of the radicand, and the denominator is the index in the radical form. So, the index. So, remember, the numerator is the exponent of the radicand, and the denominator is the index of the radical form. Okay? So, we will now write this into rational exponent, which is the square root of x. So, we have radical of x. What is the numerator? M. So, we have the 2. So, we have the m, which is equals to 1. And the denominator n, which is the square root, is the square, which is the square 2. So we have x raised to the power of 1/2 dx. So we can now identify what is the a and what is the n. So we have a. What is the a? So we have Miss Ayla, 1. It is imaginary 1. So we have integral x1 over x raised to the power of 1/2 dx. So we have the a is equals to 1 because it has an imaginary 1. Then we have n. What is the n? The exponent. Yes, Miss Jessa. Yes, 1/2. So we can now write as this form. So we have a 1 over 1/2 over n. What is the n? 1/2 plus 1 times x. N plus 1. We have n 1/2 plus 1 plus the constant c. So we will simplify. So 1 over 1/2 plus 1. So we can now add. So the denominator 2. Then 2 times divide equals 2 plus 1. So we have 3/2 x. So 1/2 plus 1, we have 3/2 plus c. So we will simplify 1 divided by 3/2. So we have 1 divided by 3/2. So we have 1 over 1 times divided by the division of the exponent fraction, which is the reciprocal. So 3/2, the reciprocal of 3/2 is 2/3. So 1 times 2, we have 2 over 1 times 3 is equals to 2/3. So 1 divided by 3/2 is equals to 2/3. X raised to the power of 3/2 plus c. So this is the answer. 2/3 x raised to the power of 3/2 plus c. Okay. Do you understand? Good. So any clarifications or questions about the power rule for integration? Anyone? What is your clarifications? Did you understand? Okay. So since there's no clarifications and questions, we will have our group activity and to test if you really understand the topic on how integrating functions that can be written as power of x. So, the same group with the previous activity, okay? So, all you need to do is answer the activity by group within 5 minutes. There are 5 items and 5 points each. So, if you got perfect, so you have 25 points all in a group. Okay, so this is for the group 1, group 2, group 3, group 4, and group 5. Okay, so your 5 minutes starts now. Three minutes left. Two minutes. One minute. Okay, time is up. So, exchange your papers. So, group 1, give your answer sheet to group 2. Then group 2 to group 3. And group 3, give your answer sheet to group 4. And group 4, give your answer sheet to group 5. And group 5 to group 1. So, we will check your answers if it is correct. So, check the answers. Is correct. Then, multiply it by 5. Okay, done. So, group 1. What is your score? Group 5. Group 2. What is the score of group 1? Okay, got 25. Group 2. 20. So, got 1 mistake. Group 3. 25. Very good. Group 4. 20. So, we got 1 mistake then. So, group 5. 20. So, also got 1 mistake. So, all in all, group 1 had 35 points for today. Group 2, 30 points. Group 3, 35 points. Group 4, 30 points. And Group 5, 30 points. So, that is your points for today. Group, for the group activity. So, okay? So, since you have no questions and clarifications kanina, so, this time, I have a question for you. So, how did you answer the activity last? Yes? They're not answering chorus. Yes, Miss Ortega. Just real. Yes, by following the formula. Okay, very good. So, do you have any clarifications? Do you really understand? Okay, so this time, we will now have an evaluation, individual activity. So, get one whole sheet of paper and answer the following equations by 5 minutes. Okay? So, answer this. Your 5 minutes starts now. Three minutes. One minute. Okay, time is up, and kindly, Mr. Shamir, kindly collect the papers. So, class, what have you learned from the discussion? Okay, do not answer in chorus. Yes, Miss Sayla. Alright, thank you. Another one? Yes, Mr. Rex. Okay, thank you. So, you're really paying attention to the discussion. I can see it. So, since there's you really understand the topic and no questions or clarifications, so that would be the end of our discussion. And I have so for your assignment, you will research and study about odd and even powers of sine and cosine to be discussed next meeting. Okay, so you have to advance study about this odd and even powers of sine and cosine. So because we will have an oral recitation next meeting. Okay, so that would be all, and see you next meeting. Okay, goodbye class. Okay, thank you.